models. I would like to first introduce Sir. Praveen Kumar Chandelia, sir, received his MTech degree at Malwa National Institute of Technology, Jaipur in 2015-14. He's currently pursuing his PhD degree in the MNIT, Jaipur. Between 2019, September 2019 and November 2019, he was with the Pattern Recognition and Image Processing Group at Michigan State University, East Lansing, USA, under the supervision of Professor Anil Kumar Jain. His current research interests include deep learning, generative models, and face recognition. So we would like to welcome Sir for this expert session in this short-term training program, which is AICTE AQIS approved and on image processing and its applications. So welcome, Sir.
Thank you, Pooja ma'am. Hello ma'am, you are audible?
Yes sir, you are audible.
Yes ma'am. First, thanks for this organizing this 6-day program, and then all my seniors and my faculties before taking my sessions. My main motto on this session is, ma'am, all participant is ready to start. Hello?
Yes sir, we can start.
Yes ma'am. My topic is phase staging and alteration using deep generative addressing network. In my main presentation, I main focus on 40% on implementations things. Autoencoder and deep convolution generative addressing network I have implemented on using Colab on the publicly available phase data sets. Then 3 model I have developed in this past 3 years. I have explained how to develop the models and which type of challenges you face in developing the generative addressing network, because model development is not easy task. This take 5 to 6 months, and then find out the novelty in this model, then quality and competitiveness. All the things I have discussed in this presentation. The outline of this presentation is, first we discuss the fundamentals of convolution, hardly 2-3 slides on this convolution network. Means what is the filter size, how to calculate what is the convolution output size, and what is the polling size. Then publicly available phase data set, and then how to generate the images. Because my topic is not related to supervised learning, my topic is fully related to unsupervised learning. I have discussed the existing available model, synthetic image generations model. Then if you work on phase data set, you must be required to process this data set. Process means crop and align. The state-of-art model discuss on the phase data set. Then after this, in 5 number, we go for the convolution autoencoder we design. I have developed this model in my paper. Same things I have a design in front of you, and then we run this code on phase data set. Then application of this convolution autoencoder means where you apply this convolution autoencoder. So for gender and ethnicity alteration purpose, and then young elder age to younger age, and younger age to older age. Then after this, find out what is the limitation of convolution autoencoder. Then in 2015, the generative addressing network is introduced. For 10 out of 6 paper, this time is coming on generative addressing autoencoder. We discuss the mathematics behind the generative addressing autoencoders. Then the loss function we discussed. Then the application of this generative addressing network we discuss, DC yarn. Then the 2 more paper we discuss, conditional perceptual adversarial variational autoencoder, then child phase. This one the first fundamentals of convolution. If you design any application based on the convolution, the main 2 layers is present, the convolution layers and then polling layer. And then convolution layer is related to means have 3 main parameter. The W is the width of your image, F is your filter size, P is the padding strike. Means all you are familiar with this concept, and 1 represent your bias. In the case of polling layer, we never read the parameters. Means parameter learning is not performed in the case of polling layer. The parameter learning is only performed in the 2 important layer, the convolution layer and the fully connected layer. How to calculate the size of polling layer? W minus F S plus 1. This all concept is very important if you develop the code. If you're not familiar with this concept, then you never be develop any deep learning concept or deep learning models. So this one.
Sorry for interrupt, Praveen sir. Sorry for interruption.
Yes, ma'am.
Are you sharing your PPT right now?
Ma'am, you are. Yes, ma'am. The phase staging and alteration using deep generative addressing network. This one the sessions topic. The first, the outline of this topic is the fundamentals of convolution neural network, means what is the stride, what is the paddings, and then what is the input size and what is the output size, then publicly available face data set, because my presentation is mostly focused on the face data set. So we discussed which data set is available in public domain, then how to generate the synthetic images, means how to convert real images to synthetic images and image generation. We discussed the publicly available a state-of-art model we discuss in this synthetic image generation. If you're going any developing model, the first step required to process your data. So how to process your data? In 4 steps, we discuss the pre-processing of our face data set. Then after this pre-processing, we develop the one autoencoder, but this autoencoder not based on the fully connected layer, this based on the convolution base. Then the application of this convolution autoencoder, we discuss ethnicity and gender alteration. Then first 6 point is based on convolution autoencoder. The limitation we address, then after limitation, we overcome this limitation using generative adversarial network. The maths behind of generative adversarial network, then the loss function, what is the discriminator, what is the generator, how their work is, what is the adversarial loss, this thing we discuss in 7 point. Then after the variant of generative adversarial network we discuss, the most popular variant is the DCGAN, deep convolution generative adversarial network we discuss. Then the application of this generative adversarial network we discuss in 9th and 10th point. I have developed the 2 models, conditional perceptual adversarial variational autoencoder, and then second one the child face. So first we go for the fundamentals of convolution autoencoder. Everyone, mostly you are familiar with this convolution and pooling layers and then fully connected layer. Whenever you develop any models based on the deep learning, have 2 main layers, convolutions and fully connected layer in present scenario. Convolution and fully connected have a parameter learning concept. What is the parameter learning concept? Means weight related things and bias related things is update in fully connected layer and convolution layer. But pooling layer is never be parameter is updated, means parameter never be learned it. How to calculate the size? For calculation the size purpose, you require the 4 important parameter. First, W for your width, F for your filter size. Generally the filter size is 9x9, 7x7, 5x5 and 3x3 or the 4x4. Then the padding and the strides. And then pooling layer, in the case of pooling layer we not discuss the padding concept. Simple concept is width minus filter, then divide by stride plus 1. This 1 represent your bias term. This one is simple neural network architecture. The input in my presentation, I represent this input with X. Suppose the input size is 83x83. This is the width and height. Layer 1 have a convolution operation. This convolution operation have a 9x9. Means the filter size is F is 9x9. Then 83 is the width. Then next one is the pooling layers. Then again convolution layers, and then pooling layer. The last one is the fully connected layer. This 101 is representation in the number of classes, or the each node representation. Then my question is how to can calculate the size of layer 2, layer 3, layer 1. So we have a simple one question. If you're familiar with this concept, you never be faced the difficulty to design the deep learning based models. If you're not familiar, then you never be design any deep learning based models. So my first main focus on how we can familiar with this thing, then go for how to design the models. Suppose the W is 83, means width of your image, input image. Filter, the size is 9, then padding is not considered in 0, as is stride. Then after first layer means 9x9 convolution, the size is 75x75. Please everyone, those who have a pen paper, please use the pen and paper, then calculate this size. This size is very important at the time of implementation. If you're not familiar, then very difficult to understand how to implement these models. The 75 means W your 83, 80 minus 9 plus padding is 0 plus 0, then divide by S plus 1, then 75 cross 75. Then 32 is the filters, means the feature map, or you say that the different type of filters. This one the first layer output. Then in the case of pooling, we never be consider the padding concept. Padding is 0. The filter means 10 cross 10 pooling and the 5 into 5 sampling. The 10 means your F value. W is your just previous layer, means layer 2, previous layer is layer 1. Then 75 minus F means 10 divided by 5. Approximately you get plus 1, 40 cross 14 cross 14. Then feature map is 64. This one the standard rule in deep learning. In your first layer, if you have a 32 feature, then next layer you have a 64 features map. Then next layer you have 128 features map. Then you next have a 256. Then next you have a 512. Then next you have a 1024. This one the standard feature map concept. You must be use this concept and never be face the difficulty to develop any models. Any doubt in this? Pooja ma'am, everything is okay, ma'am? Hello? Hello?
Yes, sir. Yes, sir.
Yes, ma'am. Because online concept is audible, ma'am, because this concept is very useful at the time of developing the models. So my main intention is to develop the models. So if this things is clear, then we not face any difficulty at the time of developing the models. Then layer 3, then means layer 3 applying on layer 2. The layer 2 input is 14 after pooling layer. Then have a convolution is 9. Then padding is 0. Then stride is 1. Then the feature map is 128. Then the after size you subtract 14 minus 9 plus 0. Then divide by 1. Stride is 1. So your size is never be reduced. Then plus 1. 16. Then next again layer 4 256. Then same way we calculate. Anyone any doubt, or for more explanation purpose I have explained with the help of this. This one is our convolution formula.
Hello.
Yes, hello.
Hello.
Yes.
Hello, sir. This is Sai Kumar. Sir, on what basis we select this pooling 0 and strip is equals to 1?
No, this one is the general example. I have developed the models in coming slides. But if you're not familiar with this concept, then we're not able to develop the models. So first I have to clear this concept, then go for how to develop the models. The selection is based on your results. Then W is 83. Then 9 is your filter size, padding is 0, then stride is 1. This way calculate the first layer size, convolution first, then pooling is this way 75 after first convolution, you have a 75 is width, then filter is 10, means 10 cross 10, then sampling is 5 cross 5. Put this formula, then you get this thing. Then next one is, this publicly available phase data set is FGNet. This one is the longitudinal data set. Longitudinal data set means same person have a multiple images. Subject means one subject. Images means multiple images of one subject. Then in image in this data set 6 to 18 images of one subject, or total number of images is 1002. This one. Then the age range 0 to 69 year. Then the average age is 16. This data set is publicly available. You can easily download on net. The next data set is audience. Then the number of subject in this one is the 2,958. This is all demographics related to data set. Then last CLF child longitudinal phase data set. This data set I have developed in my lab. In this number of subject is 919, and the number of images is 3,682. Then the image subject, this one the child data set. This is the first available data set. The age range is 2 to 18 year only. This one the school child data set. The average age of this school say have an 8. This is not available in public for security purpose. We not give this data set on public domain. Then synthetic image generation models. The different type of synthetic image generation model is available. The first and most popular model is autoencoder. In this autoencoder, you have a two main component is present, the encoder and decoder. In coming slide, we have discuss how to develop the encoder and how to develop the decoder. This initially in 1980, because we not have a GPU resources is available, we not have a computation resources available. So this data set, this model is only developed of the MNIST. This one the digit data set related, and the finding there was synthetic generation. Then after this, just in 2014, developed the variational autoencoder. Is developed this variational autoencoder is mainly used for image alteration purpose. If you require to generate female to male, male to female, gender alteration purpose, this one generally uses. Again, two main model is present, encoder and decoder. In 2015 or 2014 last or 2015 initial, they were into the Ian Gord fellow is introduced the generative addressing network. In this generative addressing network, the two important component is present, the generator and discriminator. In coming slide, we discuss what is the generator and what is the discriminator, how they work, or what is the adversarial loss. This all concept we discuss in coming slides. Then this one initial they were tested in MNIST dataset and then a CIFAR dataset. Then the variant of generative adversarial network, the three most popular variant: conditional GAN, C-GAN, adversarial autoencoder, and then DC GAN. The main problem of generative adversarial network in initial stability is the major issue. A mod collapse have a major issue. All this limitation is overcome in Sumit Chinthal paper in 2016, deep convolution generative adversarial network. In coming slide, I have developed the autoencoder concept. Then I have developed the deep convolution generative adversarial network. Before, if you develop the any model, you require to pre-process your data. For pre-processing your data, MTCCNN, multitask convolution neural network. This is the state-of-art model. Main is perform the alignment and cropping your data in required size. Maybe this required size is 64 cross 64. This required size is 128 cross 128. This required size is maybe 224 cross 224. So what is the three main network is used in this model? The first one is PNet, RNet, and ONet. What is the use of PNet? This one, the text image. This text image is resized into 16 cross 16, 32 cross 32, 64 cross 64, 128 cross 128, and 224 cross 224. This one, the pyramid architecture of image. Then randomly generate the boundary boxes on these images. Then your PNet is perform the regression on these bounding boxes and then find out the best boundary boxes in RNet, means refined network. This one have a second, find out the boundary boxes. Then ONet, finalize your boundary box based on the landmark point. This this MTCN have a 5 landmark point, 2 on your eyes, and then 1 is on your nose and 2 on your lips. So this model is only generate the 5 landmark points. The state-of-art model, with the help of this, we can generate the we can process our data. This one the result, this one the morph data set, this one the mugshot data set. This data set is not available in public domain. I have purchased this data set from Northern Carolina University. This one the initial input, the first row represent the input. You see that the phase is pose invariant phase, means the rotated 30 degree. Second phase is rotated the 10 degree. After apply the MTCN multitask convolution, this perform this alignment and cropping is performed. The size after this one is 128 cross 128, then the channel 3. So 128 cross 128 cross 3. Then second output size is 128 cross 128 cross 3 after pre-processing. So whenever we develop any model related to phase, you must be pre-process your data set. This pre-processing is general. All the models this current time is performed using MTCN multitask convolution. On GitHub, this code is publicly available. You take your data set and process this data set in any requirement size. Maybe you require 64 cross 64, you can process it. If you require 128 cross 128, you can process it. In my presentation, I have a use image size is 128 cross 128 cross, and all have a gray color images. So the channel size is RGB, means 3 channels. Then next concept is convolution autoencoder. I'm not focused on autoencoder because autoencoder is based on the fully connected layer, but fully connected layers result is not have a blurry result is generated. So for overcome this limitation, the fully connected layer I have replaced with help of convolution layer. Convolution means have a filter size, stride, and padding size is present. The 3 main terms used in convolution autoencoder. First, have an encoder. What is the encoder? This take your input image and convert into compact representation. This compact representation, the technical terms we use this technique for Z is latent vector, or maybe sometime we use the hidden vector representation. Means this 128 cross 128 cross 128 cross 3 size convert into 50 values. Then from this 50 value, we again generate this image. This generation is performed with the help of this decoder. Then for back propagation purpose, generally use the 3 loss function used in researcher. The first one is L1 loss, L2 loss, or perceptual loss. Again, I am repeating this concept in encoder, convolution autoencoder. Main have a 3 terms. The encoder concept is to convert your input image to latent representation, means the compact representation of your image. Then after conversion of your transfer your input image to Z, we again transfer this Z to image with help of the decoder. The generator represent either two symbol E or G. Then decoder we represent with help of D symbol. Then this one, the X represent the input. Then this input pass into generator in this encoder. Then this convert into Z, means this one the linear vector, means this is a single dimension vector. Again with help of decoder we can convert this concept into generated image based on the loss function. Is this loss function is used for back propagation purpose. If we develop this model using autoencoder base, then our result is very blurry. How to we can overcome this thing we discuss in generative adversarial network. So my first this model I have developed in 2019. First I explain this model is very proper way. What is the meaning of and, what is the meaning of K, what is the meaning of X, how to convolution is performed, how to deconvolution is performed. We have a calculate this thing, because this one is the implement. If this thing is not, if you have a comfortable, then you not face difficulty at the time of code development. The first, the input size is this one, the input image. This input image size is 128 cross 128. The channel is 3, not 2. This channel size is 3. Then the first convolution. In first convolution, n is 64. And stand for the number of feature map, means number of filters. Number of feature map. Then K, or we say that this one is the F. This represents your filter. The filter size is 4. I have worked 6 months on this architecture, then stabilize this architecture. All this parameter I have a tune. Sometime I apply the 3 cross 3, 9 cross 9, 5 cross 5. Then I have find out this parameter is suitable for my model. This one is the 4, the filter size. Then as for stride is 2. Then padding this time we consider as a 0. So after first convolution, means in this layer, this is the first convolution layer. After this first convolution, what is the size? Means our formula is W minus F. This one is our formula, W minus F plus 2P divided by S plus 1. You can put all this value. W means 128. Your filter is 4, means 128 minus 4 plus 1, plus 0. 0 means padding value is 0. Then divide by 2 and then plus 4, 1. Then after this, you can get the 64 is your width, height, and then your channel. Then this 32 is the batch, because whenever you develop the model, then we send the one image to model. We set our image in form of batch. So in my model, the batch size is 32. So what is the input after first convolution? 64 is the features map, the filters, different filters. 64 after first convolution, the width and then height, and then 32 is your batch size. And then general representation, width, height, C and W. After first convolution, this is the first convolution concept is covered. Then go for the second convolution. In this second convolution, my feature map is 128, and then the filter is again 4, and then stride is 2. Then we apply the stride is 2, means this side is again decrease in 2, means this 64 convert into 32 cross 128, means the feature is increasing, means initial have a 3 features. This is the very important. If you develop this model, this is the standard. 3 to 32, maybe go for 16, then 32 to go for 64 or 128, then go for 256, then go for 512. If you require beyond, then if you require to go beyond, then 1024 is the standard. Then 32 apply. Then after con 3, again we apply this concept on this layer. In this layer, the size of this one is K is 4, then K means the filter, and then stride is 2. Then you get the output is 16, means this layer convert into this 16 cross 16. Then last convolution means convolution 4. In convolution 4, again the filter size is 4, then stride is 2. Means this 16 cross 16 size is reduced to 8 cross 8 this way, and then feature is increased. Then Okay, this one, the encoder architecture. So whenever you design the encoder, means you try to reduce your input size to compact representation. This compact representation is the latent vector. So how to convert this latent vector, because this is the size 8 cross 8 cross 512 cross 32. This one is the my batch size. The 32 is the batch for one image. We not consider this 32 image. If you multiply 8 cross 8 cross 512, then you get this value 32,602. This one, the after this convolution for you have a one layer. This have a layer. The size of this layer is this one is. Then after linear, we convert this values to this 50. This one have a latent vector representation. Means we convert 128 cross 128 cross 3 image to 15 vector. This one the encoder. What is the encoder? To represent your input to compact representation. The standard value of Z is 15 to 200. This is the standard size of your Z. Z size selection is very challenging task. Depend on your results or depend on your data set. You can decide which size is suitable for my model. After converting this Z, we require to reconstruct this image into output image to go for the decoder. Anyone have any doubt in encoder concept? Hello? Hello, anyone have a?
No, sir, you can continue, sir. Thank you. We are enjoying.
Then after this one is the next task, how to generate this 50 value to image. Then go for the decoder concept. This decoder have a latent vector L. Then we require upsampling is must with the help of convolution we can decrease the size of our image. And then next step is required upsampling. For upsampling purpose, the general 2 algorithm is available: bicubic or nearest neighbor. Nearest neighbor you mostly learn in DIP paper. So how do we can increase? So this concept is known the deconvolution. So this one is our input in the in decoder. This 50 we can convert into 8 cross 8 into 512 with help of deconvolution. The algorithm used is upsampling or bicubic. Upsampling have a 2 factor. Then after this 8 cross 8 size into 16, again upsampling. Then again go for second upsampling concept. Then deconvolution. Then third 64. Then 64. 80. Then again we generate our this have a your generated output. Then this one is our input image. Then we need to calculate back propagate it. This back propagation we can perform with help of 3 loss function. This loss function is L1 and then L2, then PLA perceptual loss. This perceptual loss is based on the pre-trained model like have a VGG net, LX net. Then you maybe go for VGG phase. Based on this loss, we can back propagate our network. So main 3 encoder. In encoder, we go for convolution concept, then generate the latent vector. After latent vector generation, we can generate the output, means with help of decoder. Then we apply the neural network back propagate loss function L1 and L2. This one. Any doubt in this architecture, if anybody? Hello? Because this architecture is very important in my full presentation. If you're comfortable with this convolution concept and deconvolution and latent vector, then I'm not facing any difficulty to developing at the time of developing the code. And next, I have developed this concept, same architecture I have developed on Colab, encoder, decoder, how to introduce the loss function, how to take the input. This thing we discusses.
Hello, sir.
Yeah.
Sir, in your model, you took only 4 layers, sir. It can be more than that?
This one is possible on your data set. If you require to go for convolution 4, then again go for 1 more layer. This one have a take time, number of layer, how you can decide. You require to run your code in thousands of time. Then you find out which layer or which feature, which parameter is stabilize my results. This take time. This is not easy task to develop this model.
Sir, what about the computational complexity time for this model?
This one is depend on your convolution layer and fully connected layer. If you require to calculate the parameter, this parameter calculation is performed input layer, number of filters and the number of feature map like a 64 and 128, and then output layer. Based on this, you can calculate the full layer. I have calculated one more slide I give at the time of presentation. The learnable parameter, like in LXNet or LexNet, have a 3.8 billion parameter. So this depend on your convolution and fully connected layer size. In my model, I never be use the pooling layer. This one the standard. No one can use pooling layer this moment. All use the stride convolution or frictional stride convolution and have a then use for ReLU and activation ReLU, leaky ReLU function is uses. Hello.
Okay, sir. Thank you.
The landing parameter is you can calculate with help of your convolution and fully connected. This two layers is responsible for your learnable parameters. Means weight and bias is update only these two layers. So next, go for the implementation of this part. I have developed this code. This one I have my paper code. I have selected particular encoder concept and then design. If you develop first, this one, mostly you all familiar with the Colab. In last day, you developing the lot of model on Colab using Colab. So I have designed this model. I have tried to explain each and every concept of my model with help of this script or this. The first step you require to import the packages. The researcher mainly use the two framework. First one is the PyTorch. Then second one is TF TensorFlow, and last one is Keras. In present scenario, if you're developing your model based on the generative addressing network, my suggestion use the TensorFlow and PyTorch. I have developed this code using PyTorch. I explain. First, you need to import all these packages. These packages is publicly available. You can extract in MATLAB. You never be required to configure this package. All inbuilt packages available. The second step, you can mount your drive because my data set is available on drive. Then after mounting this data set, your Colab provide the 10.0 GB GPU capability. So we can use this capability by configure and then check this CUDA is available. CUDA is the library to use for your deep learning purpose. PyTorch is the basically one popular framework. This is developed by the Facebook. TensorFlow developed by Google. Keras is built on TensorFlow. And then 2-3 more framework is like have a Tiano, then Cafe, then Lua. But these three is absolute. No one can use this framework in present moment. Mostly use this PyTorch, TensorFlow, and Keras. For deep for generative addressing network, you go for PyTorch and TensorFlow. That is next the mounting is performed. Then after this one. Then this one the parameter Z is the latent vector, yeah, hidden vector. This one is hidden vector or compact representation. N is the RGB channel. This one the feature map, NEF encoder feature map, and then decoder feature map. The input size is 128. 128. This is my root directory where my data set is available. This data set I have uploaded it for not wasting time. This is the morph data set because whenever we load our data set, this one the format in morph, this one the root folder, in this have a subfolder is present. If you have a one class, so you present this in one folder. If you have multiple classes, so you present this data set in different folders. This one the this 0G representation, your classes is representation. Male classes 01 representation, the female classes 0T representation, male and female. This one the 0 to 5. This one the age category folders. So this one the data structure. Then morph. This one root directory. This use for manual sheet. This use for your your model give always same results and every time whenever you run it. Then after first step is initialization of your packages. Then mount your drive using mount your Google Drive. Then convert your check CUDA is available or not. Then parameter initializations of your models, like have a latent vector, then also define the root directory of your data root directory of your models, and then output directory of your results. Then this is predefined function in PyTorch. I'm explaining this function. The image size is 128 cross 128. Suppose your image size is 224 cross 224. Go for the resize, because every image in your input have a same size. ऐसा possible नहीं है you have a 64 cross 64 128 cross means different size is not possible. To mention size, then resize, because in TensorFlow or PyTorch everything is form of tensor. You never be considered as a simple array concept. To convert into tensors, then normalization means convert your data into standard mean concept. I have to take this values, the mean values, this one is standard deviation is this in the first, the second. Two things is preferred generally. First prefer this one, the second is prefer 0.5, 0.5 and 0.5. This is the second value. This is the standard value. Go for this way or go for this way. Then load this data using dataset. Dataset is the predefined package in your Torch Vision. We load this dataset, root directory, then transform. This is the transform. Means in the case of transformation, the resize concept, tensor, and the normalization. If you require to perform the augmentation of your data, means you require to increase your data size, a lot of function available in this transform function, you can use it. Then data loader, shuffle, means at the time of training, better you can make the shuffle by epoch and iteration by your data is shuffle. The base size is 64 is the base size. If your GPU capability is not suitable, then reduce this size 64 to 32, 32 to 16. Then drop last. Suppose in my image have suppose total number of images is 100, then the base size is 64. In one batch I have only allocated the 64. The remaining 36 images is not used in this model, so you mention the drop last is true, so this one is not included. Then NZ, this one is the 50, this one the latent vector size. NEF, this one parameter also used for feature map purpose. And then output size. After encoder, the output size is 8 cross 8. So this one the initializations of your data set and then parameter. After initialization of this thing, you must be go for the loss function, those you can use it. This one the standard I have a use in this my program is the L1 loss function. N1, this one is the library available. In this all the loss function is present. The most popular loss function is BC, binary cross entropy loss function. MSE for main square means L2 loss function. In my program, I have using the L2 loss function. CUDA means convert your values into CUDA platform. The first, this one the encoder architecture. This one is the my encoder. All you are familiar with the object-oriented concept. I prefer this PyTorch because this PyTorch use the fully object-oriented based concept. Class. The name of this class is encoder. NN model is the super class of available class. Have a two method in this class init, like have your constructor, and then forward. Whenever we create this object, then this forward method is automatically is called. This one is encoder. We send the input in this one. The input size, the input dimension is 128 cross 128. Then the channel is 3. Then the base size we have a 64. So this one the 64 is the base size. In the case of PyTorch, the PyTorch input format is the base size. After base size, you have a width, then you have a height, then you have a your channel RGB. Then this one the input to encoder. This one have an input to encoder. This one have a sequential. You all familiar with the Keras concept. The similar way in PyTorch have a sequential model is performed. This is the first convolution block. This is our first convolution block. This is the first convolution block. The K for 64 means K, sorry, N is 64 means the feature map. K is 4 means filter. Then padding S is 2. So in this code we have a mention is this 4 represent your filters, 2 represent your to represent sprite. Then padding 1. NC means NC represent your input channel. In input channel have a 3. What is the output channel? Have a 64. According to this diagram, have a 64. This one have a 64. Then K is 3, 4. Then S is 2. So this one have an argument. This one. Then after have a ReLU function. This one have a this one have a leaky ReLU. In my presentation, I will show that this one have a Ricky ReLU. So this one have a concept is ReLU functions. Then this is the first convolution. After first convolution, similar way, then have a 64. Then this one input to second convolution, then output is 64 cos 2 means 128. Filter is same 4, then stride is 2, padding is 1. Then con 2, this one is con 2 concept means 128, then go for the 256, then this way, this, then convolution 4. So this all 4 convolution have implemented in this way. Then what is the last layer? The last layer is the latent vector representation, means we require this. After encoding 4 times of convolution, our output is Z. This Z size is 50, but this time our size is 3 to this time our size is this time our size is 32768. So we require to convert this 32768 to this 50. How we can convert it? This thing we can convert it with the help of linear layer. This linear layer is convert your input size convert into vector form. This one have an ANZ. So this one your size, this, then this one the 50 output. How to call? Input encoder, your input size is pass. The first time is convolution. This is the first convolution, then second convolution, third convolution, and ReLU. Then this one the linear layer. This is the latent vector is Z. I have print this model. If you require to print your model, this is the simple one. The first way is print encoder. Your model is print convolution. Input size is 3, and then feature map is 64. Kernel size is 4 cross 4. Stride is 2. Padding is 1 cross 1. Then after ReLU. Then next is con 2. The second convolution. The input in this case 64. Then 120 case is the output. Then con 2 have a 128, then 256. Then next 256 have an input feature. This one is then 512. Then last layer, this one have a your input feature map, and this one is 52. If you're developing any model, you must be aware this concept. If you are aware this concept, you never be face difficulty related to your dimensionality reduction problem. Means mainly from dimension is not match. If you have a familiar this concept, means how to calculate the size of convolution layer, how to calculate what is the input to decoder, this way. Anyone any doubt in this? Hello? Because practical session is face difficulty to without audience. Hello?
Yes, sir.
Ma'am, anyone have any doubt? Please ask me, because this one the encoder I have developed it, then latent vector I have a generate. Anyone have a question? Ma'am, please.
No, sir. Till now, I think it's okay. And if participants have any query? Yes, sir. Sir, please continue.
Okay, ma'am. Then next, go for the decoder. Encoder we have a design is the next concept is how to design the decoder. Means in the case of decoder, we convert this 50 vector to 128 cross 128 cross 3. So we require upsampling it. How to upsampling? Then go for the decoder concept is. So this one have a my decoder concept. Decoder have a same methods. Init and your forward method is automatically called. This one the Z size. The decoder input is your Z means 50 value. Then dense, this one have a dense is called. So first we convert this Z into one linear form. This one is conversion, linear form. Then after ReLU function, then we call the deconvolution. Deconvolution in the case of PyTorch we implement with help of the upsampling. Means convolution is implemented with help of the convolution function, con1, 3-4 function, con1, con2d, con3d is available. Con2d related to your RGB image purpose. Upsampling nearest to have a different algorithm is available. Upsampling to indicate matlab the scaling factor is your 2. So this image size is input feature map, then output feature map, 3 is the filter size and padding, then again ReLU. Then go for second upsampling, means this one. First this layer is covered, then go for this. Then similar way, third, then fourth, then this way is generated. Upsampling 1, you see that the feature is decreasing this time. 8, go for 4, then 4, then 2, then 2, then 3, then NC means 3. So we again generate our input. Then this one, the standard rule go for last letter 10h, because the 10h range is -1 to 1. So we have a more information. If you use the sigmoid, then you have a less information, means 0 to 1 information. So whenever you develop the autoencoder architecture, 90% cases your final layer of decoder is 10h, because the 10h have a value is -1 to 1. Then this way your encoder decoder architecture develop. This one have a decoder linear 50 to convert this form. Then this pass this feature map, upsampling is performed, then final this way is generated. So this way our architecture is designed. So this one have encoder and decoder concept. Encoder we have a convolution, then latent vector, then this latent vector again convert into with help of upsampling, then we generate it. Then after we require to give the input to our encoder, then we also which optimizer we use is, so we all these things initialization, and then your input form base size. In the case of PyTorch, the format is base size. Then after have a your channel RGB channel 3, then image size is 128 cross 128. This is the input size. Image size I have mentioned is 128 cross 128. Channel I have mentioned is 3. Base size I have mentioned is 64. So my input size according to this program is 64, then 3, then 128 cross 128. Then encoder I have a convert into CUDA input, because everything in the form of input. This is variable means those variable for back propagation. So used for variable methods of PyTorch back propagation method. Then we initialize the optimizer. The 3 optimizer generally use the SGDA, ADAM optimizers is used. In generative adversarial network, all one use the ADAM optimizer. This ADAM optimizer for encoder and ADAM optimizer for your decoder. The learning rate very low, 0.001 or either 0.002 and 0.002. This learning rate setting is a very challenging task. For researcher is give the 2 learning rate value 0.001 and 0.00. This 2 learning rate is standard. If you develop your model, use this learning rate. This one the beta 1 and beta 2 values. Then have a trained model. Then I have a epoch. This one I have epoch. This one immutator. This is a data loader. This data loader have a this side. This one have a data loader. So first we load this data set. This data loader we pass in enumeration. This one is data loader. Image data means this value in the form of array. Then image label means 0 to 8 have a labels. So this label value is used. This time I'm not using the label value. Image data I have a convert, because this data is back propagation. First I am required to save the first 8 images for input purpose. So I have a select first 8 images, then repeat into 5 times to make the grid. I have make the 8 cross 5 grid, means 40 images. The 5 images, 8 cross 5 grid I have a prepared, repeat 5 times I have a repetition it. Then data, then generate, save this utility function. I have a save this thing. The result is that like that. The initial. This way I have created the grid using this line, this grid. This I have a grid. So this way you can create your grid. Then variables, save this, then convert into CUDA. Base size, the first parameter always, the size written the 4 values, base size, channel and width and height. If you mention 0, you get the base size. The set the gradient 0 to before. If you start the anything in your PyTorch back propagation concept, you familiar, all the framework PyTorch, TensorFlow class perform the back propagation in background. So first we initialize using 0 creds, then copy in temporary variables. What is the input of encoder? This line is very important. What is the input of encoder? Input of encoder is this. This one have a your input of your encoder. Input means this one is image. The 32 images is simultaneously pass input, then channel is 3, width is 128 cross 128. This input, what is the output? Latent. Latent vector, the size is, so this size is convert into 50. So this function is called, then your input pass into this encoder. This one have an encoder, first convolution, second, third, fourth, then convert into linear, then latent, this latent vector is written it. Then this one have a size, the latent vector size is 50. This one is output of decoder, output of latent vector. What is the input of decoder? The input of decoder is this latent vector. So this latent vector we pass into decoder. Then decoder take the 50 value, a simple linear vector. This one is decoder. Then size, decoder have a Z is pass. This all upsampling, first linear to convert into simple linear vector. Then upsampling, 4 time upsampling. Then your decoder is convert into again image. This one is image reconstructor. The input image size is 128 cross 120 cross 3. Then the reconstructed image size is 128 cross 128 cross 3. Then we apply the loss function for back propagation. So L1 have a loss function is input and reconstructed. This one have a loss function. This one have a loss function. This function is called pixel by pixel value is calculated. The absolute error is calculated. Then this way. Then back propagation is called. Then optimizer you can update it. Optimizer se updation matlab optimizer is related to your weight and bias. These two main parameter is. And one more thing is all this framework you never be required to initialize your weight and bias. They were automatically initialized. Then save our result on particular type. This one result. This way. I showing this thing I have shown my PPT. This one autoencoder. This one have a morph data set. I have using it. This is the first epoch size. How to create the grid. Initial have a very blurry result. Epoch by epoch, this result is generated. This one epoch 3. Anyone any doubt? Any problem in this concept? Hello?
So please explain again this code of the displaying the intermediate epochs.
Intermediate epoch, okay.
Yes, sir.
I have a generate mention iteration base. This one have a iteration. This epoch, in epoch you have a iteration. I have a save based on iteration. This result I have a save. This all result I have a save. 30 epoch I have a run it. All the result I have a save. Because if you run this program, take approximation 5 to 6 hours you take this time. Because a lot of parameter in these models. Runnable parameter is have a convolution, then fully connected, then deconvolution, then fully connected. The highest parameter in fully connected layer. This iteration, this way, I will calculate. And then I will save these results epoch wise. Epoch, output directory, then normalization, because at the input time we do the normalization and output time we again do the normalization. Save this result, reconstruct it. This one the name of this. Batch means 1, 2, 3. Output directory I have mentioned it in top of this one is. Then in same folder this result is generated. So this way you get the results. I'm again repeating it because this concept is very important if you go for the generative addressable network. First you initialize your libraries, then mount your drive to Google Drive, then convert your parameter to your CUDA, then input. This one the standard. You search on net, you usually find out, have image, tensor and normalization. Then they give the location of your root directory. Then root directory, then normalization is performed. Then batch size, shuffles you require, then you not require last this thing is, then after your loss function, then your encoder architecture. Init method is automatically called, you not required to call this one. Whenever you create, you send the input. When your forward method is called, this thing I have clear to you. When we call this thing, then your forward method is automatically called. This one is called, backtracking is performed. This forward method is called. Then input move into this way. Convolution 4 times convolution is performed. Then this size after convolution convert into linear vector. Then latent. Then this way. This one encoder. Then similar way, the input of decoder is your latent vector. This one is input to your decoder. Then reconstruct it. Then after, for back propagation purpose, calculate the loss between your input and this one, the pixel wise pixel loss, because image size is same, 128 cross 128 3, then 128 cross 23. This one, the pixel by pixel loss is calculate MSE. Then back propagation. Then after this, you save this results. Then this way you can create the grid. This grid is automatic created V utility save image function. This fixed data I have mentioned initial. This with help of this you can create the grid. Okay. Epoch 1, epoch 15, then 3, this result is generated. Ma'am, any doubt? Hello? Anyone, any doubt is related to this autoencoder concept?
Yes, do we have any doubt? I request all the participants, please ask to sir.
Because an implementation without audience is very difficult to deliver it.
Sir, the Ankur Bishwas sir has asked earlier that while unsampling, is there any loss?
Yeah, definitely. However, this region, this result is blurry form. Because you convert 50 to 128 cross 128, definitely have a loss. How to reduce this loss? Go for the generative adversarial network. You require to go for the new models. The new model name is generative adversarial network. But we generate those data set is not available in real time. This is the main utility of this model. Every model has some drawbacks and limitations. But what is the main utility? If you not have a data set, you generate it your data set. Suppose you not have a Chinese data set, with help of Indian data set, you can generate this Chinese data set. This is the utility of this model. What is drawback? Have some losses in this data set. Real is real and generated is generated. Anyone, any question?
So there is one more question in chat box.
Yes, ma'am. Because ma'am, simultaneously I require to take the PPT and code section, and then I must spend things decision. I'm not. Ma'am, can you repeat the chat question?
So the question is, can we use autoencoder for image enhancement?
Yeah, definitely. Super resolution concept is available. You remove this L1 and replace by perceptual loss. In coming slide, I have used this concept. This result I have increased in my results. In coming slide, I have a same perceptual loss. This concept is related to super resolution images. How to convert the 16 cross blurry image to high resolution images. This is available. There are a lot of research going on super resolution topic. The super resolution based on this autoencoder. Primary concept of this super resolution is autoencoder.
Thank you, sir. Now you can please continue.
Okay, ma'am. Because lot of tab is open on my. This one is your assignment. You develop this because I have developed that color image. You use this same concept, but you use the MNIST dataset. MNIST dataset is publicly available. And mostly library provide this dataset in inbuilt. Uses this one the encoder architect. Please take the picture of this and design it. In this, I am not using the. I'm using the pooling layer. Then I also mentioned the dimension of this one. I also mentioned the latent vector size, and this way is your result is generated. What is the input? 28 cross 28 cross 1, not 128. This one's 28 because the standard size of MNIST data set is 28 cross 28. Or you apply the fashion data set 1. Then implement this code, same code you can use and run this MNIST data set. Then you're comfortable with what is autoencoder or how to work on autoencoder. I have give all the size. I have give same size. You use this convolution concept, upsampling concept. Use same filter. You can use it. Then a filter size I have mentioned it, 16 cross 16 this way. Then based on this convolution autoencoder, I have developed the one model. The name of this model is a sampling and condition based deep autoencoder. The application of this one is the ethnicity and gender alteration. The drawback of this model is the image is not very plausible, means not very synthetic generate images is very plausible, means blurry image I have generated it. But this in this same encoder, sorry, this one have an encoder, same encoder, but I have used the sampling concept here. Sampling is mu and sigma based, then generate the Z. So my Z is very compact, not scattered Z. Then second encoder, this input, then second encoder, same input I have a pass in this, then L, this condition vector. I have attached this condition vector have a 3 information. In my previous program, I have not used any condition. If you require to add the condition, then condition generally is your one hot vector. One hot vector, age, gender, ethnicity, then your attributes like have your bald hair, you have a mustache or not mustache, child age, younger age. This way you can age this information in this L, then modify this L, then append this Z and L into this ZL. This is the latent space. In my first presentation, I have a convert encoder Z or decoder, but in my next slide, I have attached this encoder Y with this Z. So this, with help of this L, we can modify our Z latent vector. So this one is our image. Then we change the ethnicity of this person. Encoder decoder architecture is same. I am showing next one. This is my encoder. You can design this convolution, have an operation. Then flatten layers, flatten dense related to linear, then have a sampling. In my previous program, the size of latent vector is 50, but in this size have a 60. This is very challenging task how to select the latent vector size. This is not easy task because latent vector represent your identity of face. Identity is very important in the case of face data, in the case of face models. Then this one I have my decoder, 5x5 filters, then strides, then filter is increasing way, then activation function, leaky value I have a usage. That I also mentioned what is the size of output size. Then this one I have a decoder based on the deconvolution concept, decon 1, decon 2, decon 3, decon 4, this way. So in my previous I have used the 4x4, stride is 2, but this time I have used the 5x5 kernel, stride is 2, then filter is there. I'm not using the batch normalization in convolution layer, but I am using the batch normalization in dense layer. Where you use batch normalization, where you not use, this one is only hidden trial. You implement your code, try to run it and check my result is proper or not, my loss is decreasing or not, then you can decide or this loss function is suitable. Or second option, you can read papers. This is only one way to develop the model. Then this one have a decoder concept. Then again, last layer is the 10H. My input size, the 128. Then this one the output size of decoder. Then I have used the 3 loss function. I have used it. One have a latent vector optimizations. Latent vector optimization function. I need to this Z and L dash. This is input to my decoder. Then EZ. Then sampling. As for sampling, I have 3. 2 is encoder EZ, then 2 encoder EZ and EY, and then 1 is decoder. This one the loss function. Z is my latent vector. This one latent vector optimization. This one the L is your ground truth condition vector. Then this one input and the generated latent vector from this input. Then this MSE calculate between condition vector. This one the pixel wise loss for back propagation. I have used 3 loss function in this model, and the result is not prominent results. This is the major drawback of this model, because this model I have designed with help of the autoencoder concept, or this is the major limitation of autoencoder. Dimensional reduction have a major limitation, means you lost the data. Information can also lose. This one the female to male. This one have a male. This one the female. This one Indian male. This one the female. Indian girls. Same. One more important, age is not changing. This one the very important. Many times you are younger to elder is go, but in the age is same. The mustache is removed this way. Then this phase generation, this all, the mustache is formation. Here the mustache is not present, here the mustache is present. Boy, these girls, this have a boy, means here the mustache is present according to age. Here the all have a child, but here the mustache is not formed. So how to decide? This is all your model development task. Then Asian ethnicity, I have changed it. This one have Indian ethnicity. I have altered this ethnicity. This have an Indian ethnicity. This one have a Chinese ethnicity. This is the application of this model. Then age alteration. This one have a age, means this one have a child to make the younger. This one child, younger. Then child and younger. This one have a elder to younger. This one elder to younger. This one have a elder. This one have a younger. How this is possible? With help of this latent vector. This latent vector is very important. How to generate this latent vector? Have a three information: age, gender, ethnicity. This is the simple one hot vector. Gender, ethnicity. Based on this, I have a generate this result. This three loss function, I have a use it. The next topic is, this is autoencoder. What is the main drawback of this autoencoder? Your result is not very prominent. Your result is not flexible. Means in your output, lot of information you have a loss. How we can capture this information? In 2015, the Yarn College developed the generative addressing network. Before going to discuss the generative addressing network, first we cover what is the difference between discriminator models and generative models. The discriminator model work as like a classifier, means work on the conditional probability. Like you give an X, then predict the Y. Means X is your input, and then Y is your target. The model is learn probability of Y given X. Then conditional likelihood, means this based on the classification. The popular model is SVM, neural network, and logistic regression is come in discriminative category. In the generative category, have your restricted BOLTMOS machines, VAE, variational autoencoder, generative adversarial autoencoder, this all part of generative model. What is the difference? In the case of discriminative network, you focus on conditional probability. In the case of your generative model, you focus on the joint probability. Means given X, then predict the probability of X given Y. Means joint probability we main focus on. Then the popular one is generative adversarial network. So next for the generative adversarial network. In generative adversarial network, the three important terms is present. First one is the generator. Second one adversarial, and the network. What is the generator? Means generate the image. How do we generate this generate these models? How to generate the images using two components. One is the generator, and second one is the discriminator. Adversarial loss, the fighting between these two components. The one component is fighting one component your generator, and the second component is your discriminator. Then loss between this is adversarial loss. In coming slide, I have discussed what is the adversarial loss or network. This network is maybe your fully connected layer, maybe CNN based, maybe have your deep CNN based. This one is the network. Generative means generate the data. Adversarial have a competition between the two network. The one network is your generator, the second network is your discriminator. Then this network is maybe your fully connected layer or convolution base. This is the basic architecture of your generator. Two important component. First one is the generator, then second one is your discriminator. The first I covered the generator. The generator input is your random noise. In 90% scenario, this random noise is the Gaussian noise, 0 to 1 form. This Gaussian noise, or you say the simple latent vector, this pass to generator. This generator generate the image from this noise. This is generator. This one the fake image or generated image. Or this one have a your random distribution. Then P data is your real data distributions. This one have a your any data set. This data set is maybe your MNIST data set. This data set may be your face data set. This maybe have a your video frame. Maybe have a your audio synthesizer, text, anything, any data set you pass into this discriminator. The discriminator, this samples data, then pass this into discriminators. This discriminator work as a classifier. Means this discriminator give information. This image is real or this image is fake. For real image representation is 1, and 0 representation for fake. Means discriminator is always trained on 2 times. One train on your real image and one train on generated image by generator, means fake image. Then decide this one is real image or this one is fake image. I'm again showing with help of one diagram. This one is Gaussian distribution. This one random noise, you can generate it. This is generally the size of this noise is 100. Then this pass into generator. This generator is similar to decoder. If you're familiar in autoencoder architecture, then you not face difficulty to design the generator. Means this one have a latent vector. This latent vector is passed into this generator. Then the generator means similar to your decoder concept. Then generate the image. This one have a generated image, Z, and then generated image I have represent decode. Then what is the input? Any real or original data distribution, maybe MNIST, face data set, text data set, medical image, video, audio frame, anything you can pass into this one, into discriminator. What is the discriminator? The first train on real image, then second take on fake image. Then decide 1 for your real purpose and 0 for your fake purpose. For this purpose, generally use the sigmoid function because the sigmoid range is 1 to 0. So this one is the your discriminator train on real and fake images both. What is the what is the final objective or function to stabilize this model? Means the generated image is try to approximate this real image. Means the generated image is suppose D, then generated image is D dash. When this model is stabilized, when D is approximate to D, then your model is stabilized. And this discriminator architecture is related to encoder architecture. So they were reverse it, but they were learning in implicit, not explicit. Discriminator distinguish between real images and fake images. Distinguish between real and generated images. Real image represent 1 and fake image represent 0. Then generated image is input to discriminator. Then next one, how to derive the loss function, because generative math, a lot of mathematics behind this generative models. All you are familiar with the binary cross entropy. This one you are generated, this one the input. The binary cross entropy function is y log generated input plus 1 minus log 1 minus y hat. Y hat is related to generated image and y related to your input image, original image. And then what is the loss function for discriminator? What is the loss function for discriminator? Means what is the adversarial learning? For P data is the real data. For real data, what is the value of real data purpose? Y value is 1. What is the generated? This discriminator input is X, means real data we pass, and this generate is Y hat. When we put this Y is equal to 1 here, Y hat is dx. If you put 1 minus 1, this term is go. Then this one the discriminator loss function. Then generator loss function is, in the case of generator loss function trained on the fake related things. So fake related purpose Y value is 0. Then D is Z is the input, means the prior noise input to generator. Then this generator, then generator pass to this discriminator. Means this one the generated output of discriminator. Then this is the loss function. When we put this thing, this to Y is equal to 0 in this term is go. Then this one. So this one is to discriminator loss function and generator loss function. Then objective of discriminator, the discriminator seek to minimize the average log probability of real image, equation 7. Then a log of inverse, this one the fake image. This one have a real image, this one have a fake. This is a log function. All you are familiar with the log function. This one the maximum value, then this one is the minimum value. In the case of this first two graph is related to your discriminator, means A related to your real image, Then figure B is related to your fake image. So this one, the discriminator loss function. Your generator is only trained on the fake images. Then this one, the fake images purpose. Then this one have your generator loss function. When we combine, then this one, a final loss function is our main is what is the adversarial generator is minimization, and your discriminator is maximization is performed. This one is the stability situation. Pj is the generated data by generator. P data is your real data. This real data is input to your discriminator. G data is the input to your discriminator. Epoch by epoch, this stabilize. When this Pj is equal to Pd, means Pj approximate to Pd, then your model is stabilized. This all the things is performed implicitly. You're not required to use anything outside. Means implicitly this model is run, which data is real or which data is fake, then compete both the model to each other based on this adversarial loss function. Your discriminator is trained on 2 times, one on real and one is fake. Then your discriminator trained on your fake data. This way, this one the layout of simple diagram. This one have a real data. This one have a generated data. The first, this have a points. This one the sampling points of our data set. Yellow is generated related and gray is related to real data. Discriminator and generator simultaneously is trained one by one. First time the discriminator trained, then next time generator is trained, then second time discriminator is trained, then then next time is generator is trained. So first is discriminator, then this discriminator is trained. When discriminator is trained, what is the discriminator? To classify between the real data and fake data. So this diagram is indicating this have a real data or this one have a fake. And this is to classify this real data and fake data. What is the generator? Try to approximate the real data. Then this have a generator, then this time picture of generator. Then generator try to approximate this real data. Means उसी की जैसे बनने का कोशिश करेगा, उसी की जैसे होने के लिए कोशिश करेगा real data के लिए. Then next step is your discriminator. Again discriminator. First discriminator, second generator, then next discriminator, because adversarial means both the network is competing to each other. Means first discriminator, then generator, then discriminator, then discriminator. Means here this value is present far, then this try to move out below this line. This classify this network, then again generator. This generator is approximate to this real data. Then at the global optimal point, where the optimum point is achieved, when generator is approximate the discriminator, means like this data. This is real data, this one have a generated data. Similar one, then your model is stable. So what is the adversarial? Means discriminator is, say I have a real data is generated. Then generator, I have generated the real data. Then discriminator is discriminate between real data and fake data. It means this is force and police game. Everyone simple. This one have a thief and police game. Discriminator and generator is competing to each other. Min max game. Everyone is find out which one is the best situation. Anyone have any problem in this? Hello? Hello?
So there is one question in chat box.
Yes, ma'am. Because simultaneously.
How do you calculate the loss in neural network?
How back propagation? Back
Yes.
propagation means update the weights and bias based on the cross and based on the loss functions. Ma'am, this thing is must be familiar to the student, because back propagation is doing with help of the back propagation, the loss function is updated. It means update the weight and bias.
Okay, sir.
Ma'am, any problem in generative adversarial network? What is the discriminator? What is the generator? Hello?
Yes, do we have any problem participants related with these concepts related with GAN? Sir, please continue. There is no question right now.
I have go for one more implementations. Ma'am, this we go ahead or because take the half an hour to cover this topic. First, I only designed the next after 15 minutes. Next session, I will implement this program. Okay, this one I have a generator. First, I go for theory. What is the generator? What is the discriminator? What is the architecture of generator and discriminator? And the next session, I have a design this model. Generator have a hidden layer, four straight convolution layers. This one the feature map means Z first feature map is 1024, 512, 256, 128. Then the ReLU's activation function. Then output layer is this one the generator architecture. Then this one have a discriminator architecture. Discriminator feature map is increasing by factor 2. Then batch normalization uses this one some parameter I have a decide. This one have a generator means I have take this diagram from DC GAN paper. Have 100. Then the feature filter is 4 cross 4. Then feature map is 1024. Then upsampling it. This is decoder similar concept. Then upsampling it, then generate the image with the help of this random noise. Generate the image. This one the generated image or fake image. Then this pass to discriminator. Then this discriminator again decide as a classifier means real or fake. So generally in the discriminator architecture, generative addressable net model, no one can use the polling concept. No one can use polling concept. Batch normalization used in generator and discriminator. This is the standard ReLU activation used in generator, all the layers, and 10H the last layer. And the leaky ReLU activation function used in discriminator. This 4 is very important parameter for generative addressable network. Because the major issue of generative addressable network is stabilize. Stabilize means if your result many times is not come, if you not use this parameter, lost the informations. Then batch normalization on generator and discriminator purpose for stabilize your training, then fast learning concept purpose. And the ReLU used for generator and leaky ReLU used for discriminator purpose. Then I go for how to develop this program. The next program is DC GAN, deep convolution based. But this time I first developed the Omnis dataset because this is a very complicated architecture. Can go for next session or can we start?
Sir, we can take this in next session also if we can have.
This take time because this is generative addressable network code.
Yes, sir. It will take time, I think.
Yes, ma'am.
Yes. So now.
Ma'am, any question till if audience have asked?
Yes. Any questions to sir?
Yeah, may I ask the question, ma'am?
Yes, sir.
Hello?
Sir, actually, you have shown two methods. One is autoencoder and encoder decoder, and the generating GAN framework.
Yeah.
So, what is the time difference between these two architecture when you try to generate some medical images, sort of thing?
Time difference.
Yeah.
The time that the generative addressable network take time because this one the implicitly is run. In the case of autoencoder, explicitly you provide the loss, but your generative addressable network implicitly internally competing between two networks. Suppose I have run 1 lakh images on this model. Minimum I require 1 GPU where capability is 12 GB minimum capability, and then requirement is minimum 16 hour is minimum requirement. 16 hour. This one all challenges in generative addressable network. You require a lot of resources for generative addressable network.
Okay. Okay. Thank you, sir. I'll ask my question in the next session. Thank you.
Okay.
Thank you, sir. It was a nice session, sir.
Okay, so now I would like to request to sir that we continue with the same topic in the next session also.
Yes, ma'am.
So there is
because next we mainly focus on this and then the application of this deep generative addressable network.
Yes, sir. So I would request all the participants to again reconnect, please, at 1:45 p.m. only, because at 3:15 we will be having a feedback and quiz, and again the quiz session. So I request all the participant and respected Praveen sir also that please reconnect at 1:45 p.m. for the next, so that it will be having the whole session could be completed in the stipulated time. So I request you connect at 1:45 p.m. and we will be having a quiz, feedback, and all kind of things at the 3:15 p.m.
ma'am.
as the closing ceremony of this STTP. So
Okay.
thank you once again. Thank you, Praveen sir. Please
Thank
connect
you, ma'am.
at 5 p.m.